Hello, good morning, and thank you for having chosen this talk amongst the many offering of the conference. Thank you for watching online as well, for those of you that are in India or in Europe, in Amsterdam or in London. Let me start with a quick poll. Maybe you can reduce the volume just a bit because it's okay. Let me start with a quick poll. How many of you have developed in Swift already? In the room, you can answer if you're online as well, but I will not see you. Just a few, 2 or 3 from what I can see from here. How many of you have developed Swift on the server? And nobody. That's what I was expecting for this talk. My name is Sebastien. I'm part of AWS. I'm traveling from Europe, from Belgium to be precise. You might hear a slight touch of French accent. That's my native language as well. And in this talk, I'm going to show you about Swift, the programming language, and Swift on the server, and try to convince you that Swift is a really good choice to develop application on the server. And if you have to deploy it, maybe on AWS, but you have, of course, many other options. Talking about AWS, a small other poll, how many of you have deployed something on AWS or maintained something on AWS? The majority. Thank you, guys. Folks. So Swift is a programming language that was originally developed by Apple 10 years ago. We are celebrating the 10 years of the Swift programming language today. And it was developed as a replacement for Objective-C, mostly to develop application for Apple platform, iOS, tvOS, iPadOS, watchOS, visionOS, you name it. It's a modern, safe, secure, and fast programming language. It's very easy to learn. What I like with Swift is that you can start very small, very easily, and there is that concept of progressive disclosure. I mean, you don't need to know everything to start writing in Swift. As long as you want to go further and more advanced code, you can learn more advanced feature as you are progressing with Swift. If you never saw a line of Swift code, this is a very, very simple example. I declare a structure. It is codable, meaning that I can transform that into something else, like JSON for this example. Let means it's a constant. There is var and let. I can create an instance of that structure. I can use one of the provided encoder, like a JSON or YAML encoder, to encode my structure and print it on the console. If I want to execute and compile that code, Swift, the name of the Swift file, will compile and execute. So far, nothing really special there. The most interesting part for me is deploying Swift on the server side. And you might wonder why. First, is it possible? Yes, it's possible. That's why I'm here, you're here, because Apple is providing the toolchain for Linux as well, for Red Hat, for Fedora, for CentOS, for Ubuntu, for Amazon Linux. So there is a lot of companies that are looking at Swift on the server side as well. If you're doing front-end development and you're a full-stack developer, that's one way for you to use the same programming language on the front end and on the back end, the same framework, the same tools, or almost the same tools. And Swift by itself has many qualities that are good for the server side. First, it's fast because it's compiled natively, so it has near C, C++ performance. It's safe because you cannot have a null pointer exception in Swift. There is the concept of optional types. It provides modern construct for programming, like concurrency, for example. You have, I think, a way that makes it super easy to abstract complex concurrency behavior. The compiler will check for you, starting with version 10, that is starting now, and version 5.10, sorry. The compiler will check that you do not share mutable state in between threads. So the compiler will try to avoid deadlock and race condition for you as much as possible. There is also a huge ecosystem of library. We have driver for MySQL, Postgres, MongoDB. There is libraries for logging, for command line argument parsing, you name it. I took a few notes from more recent Oracle. There is a driver for Oracle database, Redis as well. So there is a huge community which is extremely caring, extremely welcoming. There is a forum, there is tons of online discussion, and the development is on open source. I mean, the development of the language itself and the compiler, the toolchain, and all these libraries are in open source. There is a Swift server working group as well, looking at the direction for Swift on the server side. My favorite feature is that there is no garbage collection. So the execution time are predictive. There is no pause because, hey, we need to garbage the memory. Swift use ARC, which is automatic reference counting, to automatically deallocate objects from memory when the variables are not in the scope anymore. So that all these qualities make it really good for a choice to program, to develop on the server. So what can it be used for on the server? Scripts, any task, any business process, or API. And actually API is what I'm going to show you today. I will show you how to develop an API, starting from an OpenAPI definition and deploy that to AWS to a Lambda function. If the networks and the demo gods are with us today, I'll do it live. Otherwise, I have copies on the slide so you can see the code and you can see the result on the code. When you develop an API, you have tons of questions to answer. What will be my base URL, my endpoint? Then what will be the specific path for my API? Then what will be the verbs that I will accept as an incoming request? Is it a get, a post, a delete? Maybe it affects the semantic of the API as well. How I'm going to pass parameter in the body of the request, on the command line as a query string like that, or just as part of the path. These are all questions you as a developer you need to answer, and many others. What will be the HTTP header? How are you going to report the errors? That's not even talking about how you're going to deploy that API, because if you deploy, what are the requirements in terms of scalability, of availability, of security, and all the ETs that you can imagine. One tool or specification that you can use to help you to answer this question, or at least to define your API, is OpenAPI. How many of you in the room are familiar with OpenAPI? Few? 30%, 40%. So OpenAPI is an open specification that allows developer to specify an API to answer many of the questions I asked before. So it's standard. It allows you to define your API, and there is a vibrant communities and tools that are available for OpenAPI. For example, there are tools that you can use to generate the client side. If a server-side developer gives you, front-end developer, an OpenAPI documentation, you can generate your stubs, you can generate your client-side code to access to that API. You can generate stub on the server side, you can generate documentation, you can validate your types. There is a lot of tooling around OpenAPI. So to go back to my example, in this example, I would like to create a stock quote API. So something that returns the value of a stock. You give the ticker, like ANZN for Amazon or MSFT for Microsoft, and it gives you the change, the current price, the volume trade. You know, if you work with banks, this is quite familiar for you. And otherwise, it's not very difficult. The good news is that for the Swift programming language, there are also tools that are available. So Apple developed and published as an open source the Swift OpenAPI generator. So it's a runtime in Swift for OpenAPI, but it's also a code generator. So it can take my OpenAPI YAML or JSON definition and generate code for me, client side, but also server side. It can also generate the different types that I've defined in my OpenAPI. So all that, as a developer, I can use to just, quote, quote, just include my business logic and deploy that on the server side. One of my favorite feature of that generator is that it's transport independent. What does it mean? It means that it doesn't assume the type of server-side web framework you're going to plug your code into, or if you're developing for the client side, it doesn't assume a specific URL or HTTP library that you will bind to that. So it generates the code in an agnostic way, and then later you plug a transport, like an HTTP client library on the client side or a specific web framework on the server side. And guess what? There is a transport for AWS and AWS Lambda. So we can plug that code into AWS Lambda quite easily. I'll show that a bit later. Oops, sorry for that. So you start with an OpenAPI definition. If I want to have get stock /symbol equal AMZ, my OpenAPI definition would be something like that. I define a path, which is /stock here, if it works. Yeah, it works. The HTTP verb will be get. I give a name, get quote, to my operation, and then I define the parameter its name, its symbol, it will be in the query string, it is required, and the schema, so the type of this parameter, it's simple, it's just a string. If I want my API to return something like that, I also need to define the type for that. I'm not going into the details, but basically it's a JSON object that has 1, 2, 3, 6 properties that are a mix of number, string, or date time. So that's the YAML definition of my JSON type. So I start with that. If I start a project in Swift, I receive a file, or there is a file in the project called package.swift that helps me to define the dependencies and the build target for this project. So it's like a BOM file in Maven, for example, if you're familiar with Java. So all I have to do to include the OpenAPI generator is just add the dependencies. And there are 2 dependencies to add. One of them is the Swift OpenAPI generator that will help me to generate the code. And the other one is the runtime that will make the marshalling of the arguments at runtime. And the generator is provided as a Swift plugin. So a Swift plugin is a piece of code that can be executed when I build my code to generate the code. So every time I build the code, the Swift plugin here will look at my OpenAPI definition and generate the Swift type for me automatically. So it ensures that my code stays up to date with the OpenAPI document if I ever change, which we do all the time in a project, if I change the OpenAPI document. Then my implementation is pretty standard. Let's have a quick look. I import foundation. That's bring me foundation classes like the JSON encoder, for example. I import the OpenAPI runtime. I define a class, a struct, that implements the API protocol. API protocol has been generated for me automatically based on my OpenAPI definition. There is a function there that I must implement, and it's the same name as the operation ID I had in the OpenAPI YAML file. It has an input, it's asynchronous, it might throw an error, and it returns an output. And these input and output type have been generated for me automatically based on the type definition I have in the OpenAPI YAML file. And then it's my business logic. I read the input, I do something with that. For my demo, I will make it super simple. I generate random numbers. So if you own an SFT or Amazon stock and you see weird price on the screen, don't get stressed. These are random numbers that I'm generating. Then I just return an OK HTTP 200 message. To build, Swift build, I wait a bit, and I should get the result. Do I still have everybody with me? At least the ones in the room. If you're online, sorry. I can. Yep, good. So let's see some live coding for that. Oops, I have a certain age. I need my glasses to do that. So I start with an empty project. There is nothing in this directory, and I will create a skeleton Swift project. Swift package init type executable because I want the project to be runnable. I will execute that project. Let's open that in Visual Studio Code. I'll make it a bit bigger. Is it large enough from the back? Yes. Okay, good. I have my package.swift. I have a generic and very simple hello world code that has been generated for me. And by the way, there is a Swift plugin for Visual Studio Code that allows me to work inside Visual Studio Code. The first step would be to import the dependencies. There is a quite long text to type, so I will cheat a bit here. I will copy paste from an existing project that I have here, and I will import my package.swift into this project. So there is nothing mysterious here. This is what I show you on the slide. There are the 2 dependencies, the plugin, and that's pretty much it. The second thing I'm going to do is to import my OpenAPI definition. I'll show you these 2 files. And while I am at it, I'm going to import the quote service. I'm going to show you these 2 files or 3 files and what they are, what they do. But while I'm doing that, I'm going to build my project, because building requires downloading the dependency, compiling all the dependency. It can take a bit of time. I don't want to wait for that with you. So now that it's hopefully going to start to build, let's have a look at these. So this is my OpenAPI document. It's the same as the one I show on the slide. It has a type definition for the result. It has a stock. I made a small difference here. I don't use a query string with a name equal value. I just pass the stock there. Get quote is the name of my operation. That will be the name of my function in the code as well. The parameter is a string. It returns 200 response with a quote. That's the big schema that you saw before. It might return also a 400 or 404 type of error. There is a small configuration file for the plugin that says what to generate. I want to generate server-side, stop, and also my types. And yeah, that is expected. And then I have my code, and the code is the exact same copy of what you saw on the slide, so I will not go through that again. What is interesting here is that the plugin generated code for me. It didn't generate a client because I didn't ask that, but it generated a server-side code. That's a stub I can use. That's the famous API protocol that you saw on the slide. And it generates the type for me, so the input and the output based on the type definition that was available in the OpenAPI package. I have a linker error because there is no main entry point for that service. This is expected. I'm going to fix that in the next demo, but there is no compilation error. So I have my OpenAPI server-side code almost ready to deploy. So how can I deploy that? That's the rest. I'm going to deploy that on AWS and AWS Lambda. Lambda, it's a compute service. It's a serverless compute service. So serverless, this is not this. Serverless means, can you see the slides? No? Yes. Serverless, it's not that. Serverless means that you don't have to manage the server. Someone else is taking care of that. So by managing the server, I mean creating virtual machine, installing the operating system, installing a language, a runtime, and patching that over time to make sure it stays current. We do that for you with AWS Lambda. With Lambda, you as a developer, you write your code, you deploy your code, and that's all that you care about. The scalability from 0 to thousands is taken care of automatically, and you only pay for what you use. So if nobody is calling your Lambda function, you don't pay for it. If someone is calling your Lambda function, there is a tiny price per invocation. It's 20 cents per millions of invocation, and the first million is free every month. And there is a price per CPU time. So the longer your Lambda function is running, the more you're paying for that CPU time. You can write Lambda function in Python, Go, Ruby, Node.js, Java, C#, TypeScript. Swift is not there, I know, I'll come to that in a minute. And you can package your code as a zip file or as a Docker container image and to deploy that to AWS Lambda. Of course, you need something to invoke your Lambda function. A Lambda function by itself is not super useful because nothing can call it, or you need to use the AWS API to do so. So typically, developers are going to put an API gateway in front of it. The API gateway is an TLS endpoint. So that's the part that receives the HTTPS request from your customer. It will marshal the parameter, the HTTP header, apply some throttling, verify authorization, for example, and then forward all that payload as a JSON file to your Lambda function. As a JSON file, that's quite important for the rest. It might be also a GraphQL API if you prefer so, or it might be a message queue, so you have a message arriving in a queue that will trigger your Lambda function. It might be an event in a database, like a modern trigger for your DynamoDB application. It can even run on schedule, so you can schedule a Lambda to run every Monday morning at 9 a.m. if you have some kind of batch job to do. How do you deploy a Lambda function? You can use the AWS command line, blah, 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 create function, that's the name of the API. You give the path to your zip file, a couple of other properties, and voila, you have your Lambda function up and running. That's not super useful. How are you going to delete this environment? How are you going to create other services? I told you, most of the time you have queue, an API, a gateway, a GraphQL gateway. So in the cloud, we prefer to use infrastructure as code, as you probably know. So writing code or description in YAML or in JSON that describe the infrastructure I need, and you pass that to a tool that will generate the infrastructure for you. There are many different ways to do that, third party like Terraform, or from AWS, CloudFormation, the CDK, the Cloud Development Kit. For this example, I'm going to use Sam. So I want to introduce you with Sam. Sam, this is the audience. This is Sam. Sam, it's serverless application model. It's a tool and a framework to develop and to deploy serverless application, Lambda application. With Sam, you just define your template. You define the infrastructure that you need as a YAML file, and it will generate that for you in the cloud. So here I define a Lambda function. I give a name, HTTP API Lambda, that's the name I choose. You can put whatever name. The type, it's an AWS serverless function, so it's a Lambda function. It will run on ARM64, why not? It's cheaper, it's better for the planet. The zip file, it's there. And I can pass environment variable like a log level that depends on your code. But in the same template, I also define the events that can trigger that Lambda function. I give a name, the type, HTTP API, and it should be called on get/test for this example. It means that it will create an API gateway that will be configured to call my Lambda function whenever it receives a get on /test. I give that to a command line, Sam deploy, and it creates everything for me in the cloud. It's a bit magical. Sam delete, it deletes everything automatically. So how can you write Lambda function in Swift? Because remember my slide with all the programming language? Swift was not there. Good news, you can bring any programming language to Swift as long as it runs on Linux, Amazon Linux, because that's what Lambda execute. You can code in whatever language you want. I already developed Lambda function in Bash shell script. It works. It's not super useful. It's great for a demo, but in practical life, probably not a good idea. We have tons of customers. I was talking with a very large customer, a bank in France, yesterday or the day before, that tell me they are developing in PHP in Lambda. We have customers deploying COBOL on Lambda. You can compile COBOL with Microfocus compiler on Amazon Linux and deploy to Lambda. And you can run a Swift function as well. All you need is a runtime. So some piece of code that will take the event from the Lambda runtime and pass it to your code, like a bridge between the Lambda services and your code. So you need to write a Swift runtime to be able to deploy your function. Good news. Sorry, I'm going a bit ahead of myself. So good news is that someone wrote that Lambda runtime already. And again, it's Apple that wrote a Swift Lambda runtime. It's open source, it's available on GitHub. We are heavily working on that project right now. I say we because I'm a contributor to that project as well. So the Swift Lambda runtime is the glue between the Lambda service and your Swift code. So in my code, you know, on Swift now, we start with package.swift. You saw that already. All I have to do to write a Swift function is to add the dependencies on the runtime. There are two dependencies, the runtime itself and the events. The events, it's a collection of data structure that maps the JSON that your Lambda function that might receive. If the event is coming from SQS, from S3, from API gateway, we have different Swift structure, data structure to represent that. And that's pretty much it in terms of dependencies. And then the code is extremely simple. You start by importing the runtime. You create a struct, a class that implements one of the protocol, like simple Lambda handler. And then you add a handler. It's one function. That's the entry point that the runtime will invoke. It received an event. In that case, it's an API gateway v2 request. And it asynchronously respond with an API gateway v2 response. That's the JSON that you're going to send back to Lambda. And in between, you put whatever you want. That's your business logic. Here, it's a very simple example that collects all the HTTP header, encode that as a JSON, and give it back as an answer. So it's like an echo function that produce whatever it receives. Okay, Swift on Lambda. Do I still have everybody with me? I know it's going fast. It's a lot of information that you have to receive. I'll show you that. Then you might wonder, how do I compile? Swift build. Okay, that's pretty much it. But if I do Swift build here, it will produce on my Mac a Mac executable. And Lambda, it's not running on Mac. It's running on Linux. So I need to produce a Linux executable. So we wrote a plugin, a Swift plugin for that will actually invoke Docker with Amazon Linux and Swift pre-installed in the Docker image to compile to generate a zip file with a Linux architecture that I can deploy on Lambda. All I have to do is Swift package archive, disable sandbox. It's because to talk to Docker, we need to have network access on local host, and the Swift plugin system is extremely sandbox, so we need to disable that sandbox. Swift package archive, and it generates a zip file for Linux. How do you deploy that zip file? Remember my friend SAM? I just need to write a SAM template that will reference two things. First, the runtime. The runtime says provided, so I mean, I'm giving the runtime. I don't want to use the Java or Python runtime provided by Lambda. And is it here? Yeah, code URI, a reference to my zip file, the zip file produced for Linux. That's pretty much it. Again, SAM deploy, and it generates the infrastructure for me. With SAM, you can invoke the function locally as well. SAM local testing, it will take a JSON file, invoke your function locally. So it's great if you want to debug your code before actually deploying your code to Lambda. It helps to shorten the deploy, debug, develop cycle. So it produces a lot of output, but the important one is the log message I had in my function that I show you. Okay, so you have the different piece. You have Swift on the server. You have OpenAPI to develop API in Swift. You have Lambda and Swift on Lambda. Now let's bring OpenAPI to that picture. Imagine that you're developing a stock quote front-end application, and you need to call the get stock symbol blah 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 API on the thing that we just deployed. How can we do that with OpenAPI? Remember the OpenAPI generator and runtime for Swift? I told you that it generates client code, server code, and it's transport independent. So we need to plug a transport now, a transport for Lambda. And the good news is that there is one, and it's open source. I developed that one, and feel free to contribute to that project if you want to add more documentation, more feature. The only thing I need to do from a Swift project perspective is to actually add, oops, sorry, it's the next one, add the dependencies. So there are 3 dependencies to add to my project, the 2 to make a Lambda function that I show you already, and 1 which is the Swift OpenAPI Lambda. So it's the glue between the OpenAPI runtime and the Lambda function. From my quote, my code, which is also my quote perspective, I only need to do 4 changes. So the first change is to import the OpenAPI Lambda transport. The second change is to make my project executable, because the code inside the Lambda function needs to be an executable. And in Swift, you just need to tag it with main. I need to implement the OpenAPI Lambda HTTP API. So that's the glue between the payload that I'm going to receive in the Lambda function from the API gateway and the code of the Lambda function. And I need to add a specific initializer to register that specific transport on that specific class. So only 4 lines, or 6 lines if you indent it correctly, of a change in my code. And to deploy the same, Swift package archive will create a zip file, and then I need to create a template YAML, but you saw the template already. The only difference in this template is I want the API gateway to forward any request from any HTTP verb on any path to the Lambda function, because the routing between the path, the argument in the path, and the HTTP verb, and a specific function to handle that, it's done by the OpenAPI runtime. So I don't want the API gateway to do any type of routing to different Lambda function. So here I use the HTTP API gateway as a proxy. So for any method and any path, it will pass it to the Lambda function, and the routing, depending on the HTTP verb and path, will be managed by the OpenAPI runtime. Yes, you don't have to believe me. I'll show you. To deploy, SAM deploy, and it should work. So let's start. How much time do I have left? Still 15 minutes? Perfect. So where did we leave the demo. The demo was here. So that's my project that is already prepared for OpenAPI. Let's transform that as a Lambda function and deploy that as a Lambda function. You can see my screen? Yes, you can see my screen. The first thing I need to do is to add the dependencies here for the Lambda runtime and the OpenAPI transport. So again, that's 3 long lines of code that I don't want to type in front of you. Otherwise, it will not work in 15 minutes. So let me paste this. And we have to tell the linker as well to add this module to my binary. So these are the 3 other lines here in the product dependencies. So these are instructions for the linker to actually link my module. Let's already build that because the build will fetch the dependencies and compile the dependencies, and it might take a bit of time to do so. And during that time, let's make the modification here in the code. So I told you 4 modification only. Import the OpenAPI Lambda, that's 1. Transform this code as something executable. Implement the OpenAPI Lambda HTTP API. I always forgot the exact name. I know I developed that, but you know names, it's something that is always difficult. So it's OpenAPI Lambda HTTP API, that's correct. OpenAPI Lambda HTTP API cases. Thank you. OpenAPI Lambda API. Yeah, thank you. And then I just add an init method. I think it was suggesting one for me. That's this one. Oops. Self register handlers on the transport I receive, and I think this can generate an error, so I have to say try. It will throw the error if it is not done. So let's Swift build and ensure there is no error. And now we have build complete. If I zoom like that, you can see that. Yes, we've build complete without error. So the next step would be to package that, disable Swift package. No, first archive, and then disable the sandbox. So this will trigger a build inside Docker that I forgot to start on this machine. I rebooted my laptop this morning. You know, there is always something. Is it starting? Yes, it's starting. The image is up to date, so it don't need to download the image. The only downside here is that it will recompile everything because I'm compiling for Linux, so it cannot leverage any of the builds I made for macOS. It's like a new build. And if you look in the build directory, I will soon have, yeah, it's a bit too early right now, but I will soon have 2 different outputs, one for ARM Apple and one for ARM Linux as well. So let's continue that. So for change, import the library, main, OpenAPI Lambda HTTP API. Thank you for the spell check online, and register this class as on the transport. That will soon generate a zip file that I can deploy on Lambda. And to deploy it on Lambda, I'm going to use a SAM. So while it's compiling, let's take my template.yaml file here and add it here. So let's have a look at that template file. It creates multiple resources, a Lambda function that I call code services. The type says it's a Lambda function. And the path of the zip file will be there in my build directory under plugin, blah, 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 blah. I should have very soon. No, it's still compiling. I saw build complete. I was saying, yeah, that's correct. That's quick. I defined a timeout. I defined that the runtime is provided. It's an Amazon Linux 2, the memory size, the architecture, and environment variable. So that's for the Lambda function itself. For the events, as I told you, it's an HTTP API in proxy mode. So any HTTP verb on any path will be passed to my Lambda function, and the OpenAPI runtime will correctly route to the get quote operation if it is on /stock something. Otherwise, it will return an error for me automatically. The only thing that I add here, I didn't show you there, it's the Swift API endpoint as an output, so it will display the address of the HTTP API gateway, so I can demo it in front of you. And the time it took for me to explain that, we see that we have the quote service archive that has been created. And again, it should be here, plugins, output, plugins, sorry, oops, outputs. And I have the zip file, which is here, zip file here. Okay, let's try to deploy that zip file now. Let's make a bit more space so that you can see that. So to deploy, I'm going to use SAM deploy. The very first time, I will use the guided argument because it has to collect additional information from me. So what's the name of the stack I will create on AWS? Stop quote demo. In which region? I know there is a region here in Cape Town, but I don't have access to it, so I deploy to the US. Sorry for that. Confirm my change before deploy. No. Allow the CLI to create additional role if it is needed. Yes. Disable rollback. No. That's important. Quote service has no authentication. That's a really, really bad practice. Don't do what I'm doing here, because anybody with the URL will be able to call my Lambda function, and I will be charged for that. So is it okay? Yes, because it's a demo, and only because it's a demo. Okay, please don't do that in real life. Save argument to a configuration file. Yes, so it means next time I deploy, I don't need to enter all these again. It will be saved in a file called samconfig.toml. SAM has the concept of multiple environments, so it can deploy on debug, a test, a production, development environment. Here, I just call it default. And the SAM config file has been generated here. Now it uploads my file, my zip file to S3, and then it will start the creation of the environment itself. So okay, the network seems good. We will have, it's a small zip file, or small. It's a few dozens of megabytes. Come on. And once it's there, it will initiate the deployment. So it will create a Lambda function, create an API gateway, configure the Lambda function with my code from the zip file, configure the API gateway to be a pass-through, a proxy mode to the Lambda function, create proper AWS authorization, we call that roles, that allow the API gateway to invoke the Lambda function. And in a few minutes, it should return the URL. So let's deploy it and finish with something that I like really, because it's a project I contribute to produce. With the help of a student, we create a Visual Studio Code extension for Lambda on Swift. So all the steps that I did here to write code, skeleton code, compile on Linux, and deploy, generate a template, you can do that graphically from Visual Studio Code as well. So if you go to Visual Studio Code on the marketplace, there is, if you search for AWS Swift, there is a Visual Studio Code extension that is available here. And to use that extension, the only thing you need to do is to invoke AWS Lambda Swift, and it starts a really nice I found it really nice, but I'm not a graphical designer. As a developer, a really nice user interface. So I define my project, like a test, the region where I want to deploy that. I choose amongst a couple of templates. So these are skeleton projects, like empty projects. If you want to make an API to Lambda, an SQS to Lambda, S3 to Lambda scheduler, or the one I demonstrate now, an OpenAPI to Lambda. You choose the branch. All these projects are in a GitHub repository, so they will evolve over time and stay current. We have a README file that explains what is this template about, and you just click initialize. And initialize will actually clone the project and open the project inside Visual Studio Code for me. And then I have a button to build the project, a button to invoke the project locally, a button to deploy the project. You just give a stack name and you deploy, and a remote invoke to test your remote Lambda function. All of that graphically, it generates the project for you, and you can manipulate it graphically without typing any command line. So it's a very cool way to start a new project or to learn about Swift for Lambda. In the meantime, my infrastructure has been deployed there, and I have the output provided by Sam, and I see that the URL now it's here. So let's go back maybe here and try to invoke that URL. If I don't give any path, it should return an error because there is no path. So if I remember well, it was stocks and then a stock quote. And if I do that, you can see that. Again, it's a random number. Don't be too happy if you have an Amazon stock in your portfolio. That's not the current price today. And it works for any stock because I'm not checking. So in a few minutes, I implement an OpenAPI Swift Lambda function and deploy it serverless on AWS. Let's recap what we talked about. We start from an OpenAPI definition that gives you the list of methods and parameter input output for your REST API. I talk about Lambda, serverless compute. You can deploy code. You only pay per invocation. If there is no invocation, you're not paying. You don't have to manage any runtime. There is no operating system or programming runtime to manage. I show you SAM, which is one of the many different ways to do infrastructure as code on AWS. SAM is better suited for serverless projects. Maybe you know the serverless framework, that's roughly equivalent. SAM is from AWS, serverless framework is from the community and open source. And then I show you how to link all that together, write an OpenAPI definition, implement the Swift code or generate the majority of the Swift code, implement just your business logic, deploy that on Lambda using SAM. Wow, that was a lot of content, I realized, for only 45 minutes. Hopefully the session is recorded so you can watch it again in slow motion. And now it's your turn. What are you going to build with this type of technology? Thank you for having listened to me. We still have a few minutes, like 1 minute for questions, but I will stay outside of the room. And of course, I'm available all day if you want to talk about anything related to AWS, anything related to serverless on AWS or Swift on the server. Thank you very much. One more thing again, I have a voucher for you. So if you want to try that on an AWS account, just scan this QR code. There are 4 anonymous questions about this talk. Give us idea how to make it more informative or more helpful for you. And at the end, you should receive a code that you can redeem on your AWS account. That works if you are online as well. So you can scan the code. I have like 100 code to distribute today. So the first 100 person that will answer the 4 questions will get a code. Thank you. And that's a way to get twice applause. Yeah, I can finished in terms of question, or we have time for questions? Oh, perfect. Let's go. Yep.
Is there any advantage to running on the EC2M chips instead of Lambda's Linux?
What do you mean,
hardware?
EC2 M chips?
So the Apple ARM chips.
So in EC2, yes, there is an instance type called macOS. It's really Mac Mini that are running inside our data center. These are more for development use case than for a production use case. You can run this type of code on a Mac, but then you need to bring your own web server. You need to have some kind of load balancer, multiple Mac, and the Macs are running 24/7. So you will pay by the second every time the Mac is running. So the big advantage of Lambda is that it will scale automatically, including scaling to 0. If nobody's calling your function, you will not pay for it. If you deploy that code on a Mac, you will pay 24/7, even if nobody is using your function. So typical use case for EC2 Mac, it's a CI/CD to automate the build, test, and deployment process, just like you do with your Linux application or your whatever application with code build, for example. That's the typical use case for EC2 Mac in the cloud. Does that answer your question? Okay, cool. Any other question? Can we see the online questions as well or not? Okay. Perfect. Let's continue discuss outside. Thank you very much.